Now let's look at 45-degree reference triangles in quadrant 1. You'll see this is pi over 4. The radian measure with the denominator of 4 will always relate to 45-degree angle. In quadrant 1, pi over 4. Quadrant 2, we have 3 pi over 4. Similarly, in quadrant 3, we have 5 pi over 4. And in quadrant 4, we have 7 pi over 4. Lastly, let's look at reference angles for 60 degrees. All reference angles with 60 degrees relate to a 3 in the denominator for the radians. So here we have angle 60, it's pi over 3, 2 pi over 3, and then quadrants 3 and 4, we'd have 4 pi over 3 and 5 pi over 3. Let's look at the reference angle for pi over 3. We're going to use this to help us discuss how to determine the trig functions. If you recall from the notes, in a unit circle, the radius is always 1. As you spin each of these triangles around, you see that the hypotenuse, the end of the hypotenuse, follows the outer edge of the white circle. Now recall from the unit circle, the coordinate of the end point of each hypotenuse is x comma y, and the x and the y. And because these are angles in standard position, this means that these coordinates map to cosine of theta and sine of theta. So on this 60-degree reference angle at pi over 3, the x-coordinate can be seen along the x-axis because as 1/2. Because cosine of 60 degrees is adjacent over hypotenuse, which is 1/2 over 1, or just a half. And the y-coordinate is the square root of 3 over 2, because the y-coordinate is sine of 60, which is opposite over the hypotenuse. If we move to 5 pi over, if we